Hey, so welcome to another video. In this video, we're going to talk about strings and input and output. Strings, the best way to think of a string is think of it as being text, like what you type on a keyboard, something like that. In Python and in a lot of programming languages, we've got to start and end a string with single or double quotes, depending on the language. For Python, we can use either, but we have to stay consistent. In other words, we've got to start, if we start with double quote, we got to end with a double quote. If we start with a single quote, we got to end with a double quote. Therefore, something like this, where we have a double quote, hello, end with a single quote, this will produce an error in Python. The reason why it creates an error is because it's looking for the double quote to know where the text ends. Now, you and I look at this and we know where the text ends, but the compiler doesn't see the text the way we do. So it's looking for the double quotes. It's not finding it. So it produces an error. And in most cases, it'll produce an error that's similar to what we see here, where it says unterminated string terminal. Unterminated string literal, which means that it just cannot find the ending double quote. So one of the things we can do with strings is we can put them in variables, like what we have here. A is equal to hello. We can output A, get the value of hello. Now here in Sony, feel free to type these in. That's going to be one of the best ways to learn a new language, is to try it out. So down here in the shell, type it in and see if you get the same thing I get. Now, in some of my examples, I will have double quotes here. It's equivalent as having the single quotes. It really makes no difference. You just got to stay somewhat consistent. Now, the reason why I like using double quotes instead of single quotes is every once in a while, in some of your text, you may have a single quote. Let's say, for example, Billy's car. This outputs pretty nicely. It's easy to read. You can use single quotes and have a single quote inside there, but you've got to do some weird stuff that looks really funky to make it work. I say just keep it simple and do kind of what I've got here. Now, with strings, we can add strings to other strings. Like, for example, here we have hello world, and it produces the value hello world. I'll leave that as an exercise for you. On the other hand, the reason why this works up here is because this is a string and this is a string. Python knows how to add two strings together. It does it like this. Notice I have a blank there, and that blank goes right there. If I just had hello plus world and didn't have the blank, it would put these two together. Now, what I've done here, though, is I've got a blank there and a blank there. You don't need both of those. Technically, there should be two blanks there instead of one. So that's just an error that I've created myself. You can try that. You can try removing one of these blanks here, see what difference it makes. What if we want to add a number to a string? So let's say we have a variable called num set equal to 146, and we want to add these two together. So we have a string plus a number. In Python, this produces an error because Python does not know how to add a string and a text together. If you want to add string and a text together, there's some ways to do that. We spent a lot of time in this chapter talking about it. One way to do that is the following. Create your variable. Now, of course, you don't necessarily have to do that. You could just put 42 right here where it says number. But I like sometimes using variables because most cases in your program, going to be using variables. Because you know, if this is 42, you would just type in 42 there. But having the variable, it knows to look up the value that's in number, substitute it here. So this string here, this %s, think of it as a placeholder, and whatever values in number is going to be put there. The percent tells Python that this is some kind of we need to do some kind of conversion here. And the S says that it needs to be a string. It's expecting it needs to output the string representation of whatever's in here. So it takes the value of 42 and substitutes it here, and it says the number you entered is 42. Strings versus numbers. We've kind of touched this briefly, but we'll go into a little more depth here. We already know how to add two numbers together from previous lectures. 1 plus 1 is 2. We try to add two strings together. We know how to do that, and we come up with a string that's 11. Notice this isn't 2, it's 11. It takes this string and appends on the value or concatenates the second value here onto this one. What happens, and we've already seen this in the example above, what if we have a string and we add a number to it? Well, we get an error. It says it cannot concatenate a string not to a string. Or it can only concatenate a string to a string. And this says that it cannot do an integer value, which is what 1 is here. If we do it the other way around, what's funny is we get a slightly different error, but they mean the same thing. The reason why is because it sees 1 plus and it thinks, oh, we want to do arithmetic here. 1 plus some value. And then whenever it gets here to the string, it goes, well, this string is a number. And that's why it gets confused and it gives this slightly different error here. Is because this error deals with arithmetic of like numbers, adding numbers together. This one, since it has a string here, it sees this as a concatenation operator, where this one here is seen as an arithmetic. That's a little bit beyond scope of this class, but that's really what's going on here. That's why we're getting these two different errors. Now, to complicate matters or to confuse matters, we can use the multiplication on a string, which you go, well, wait, if we can't do arithmetic, or if we can't do addition, why? How can we do multiplication? Well, really, this is just shorthand to say take whatever's in the string, and we want to duplicate it this many times, which in this case is 3. So we have equals, and it outputs equal 3 times. And actually, this is supposed to have this is a string, so it should have a tick mark on both sides. This is an error. I'll have to fix it in the notes. But as you can see, if you go down here in Thony and you type, you see you get the string here. Now, what if we want to convert a number into a string, or vice versa? Well, got a number and we want a string value. We want to put that like in a variable or something like that. There is a string function called str that will take a value and will return the string representation of that. So an integer will return a string representation of, of 1 as text. String will take the value of 3.14. It knows how to represent that as a string, so it puts it out this way, which is what we expect. Now, to go the other way, where we have a string and we want an integer, there is an int function that will take a string and return a number representation of that, or integer representation of that. Since 1 can be interpreted as an integer, it can return this value as an integer of 1. A float, there's a float function. We can take a string, 3.14, it knows how to represent that, so it represents that as 3.14. Now, the int and float functions are a bit flexible, which means that if there is some white space or like spaces in front and after the numbers, it will ignore those spaces and go just directly to the number. This is sometimes handy if you're getting user input from somebody and somebody maybe hits the tab key or hits a space bar a couple of times. Python is a little bit forgiving and will just ignore those spaces and just grab the number that's there. So for example, we have a bunch of spaces, then 1, 2, 3, and then a bunch of spaces. It knows to interpret that as 1, 2, 3. If we have some beginning spaces, and then 4, 5, 6, let's say the beginning spaces, or somebody hit the space bar, or they hit the tab key, it knows that that's going to be the number 4, 5, 6. And same thing with 7, 8, 9. It knows that that's going to be 7, 8, 9. But on the other hand, if somebody does something like this, we have a string of some spaces, a number 1, some more spaces, a 0, and then more spaces, it's going to get confused because it doesn't know how to convert this to an integer. So what it does, it plays it safe and just says, hey, I cannot convert this to a number. So it just outputs that error. Now, let's say that we've got a string, we're not really sure what's in it. Let's say, for example, it's actually a float value in the string, but we're expecting an integer. What Python will do is just look at the integer portion of this value and output that value. So it will ignore everything after the decimal point and just output the value of 3. So if there was a value of 3.99, for example, this just still outputs 3. It will not output 4. It does not do a rounding. It just looks at the integer portion and outputs that value. Now moving on, let's look at some other common string functions. Now a lot of your code, quite often what people will do if you use Python out in the wild somewhere at a job or something like that, is quite often you will be taking text from a user or from a web form or from a database or from a file, something like that, and you got to do something with it. Sometimes you'll have to take strings, text, and convert that or do something to it, to perform some function on it. For example, there's times that you may have a string and you want to count the number of non-overlapping occurrences of some kind of a letter or subsequence of letters in that word. And so we have a function called count that allows us to do that. This is the syntax of count. You have some string, dot, and then the word count. Then you have the word that you're looking for, or the letter, the sequence of letters you're looking for. Best way to look at this is look at an example, because sometimes just looking at syntax doesn't make a lot of sense. So let's say we have the word Mississippi. We want to see how many times the letters IS is in the word Mississippi. This comes up with 2. You notice here's the first occurrence right there, and then the second occurrence is right there, and it has to be in that exact same order, IS, not SI, but IS, so we get 2 occurrences. Now, the second value here that we have in our function, or second argument here, is called start, which means that we can ignore some of the letters at the beginning. So in this example, where we have Mississippi, we want to count the IS, the number of IS in it, but we want to ignore the first 3 characters. We would jump to right here to the S and start counting how many ISs there are. And of course, in this example, we only see 1. If we want to look at the end, Maybe we don't want to go all the way through the whole word. We only want to go through so many letters of the word. We would put another number out here, a comma, another number, which would tell us to only look at so many characters. Another function that we use quite a bit with strings is the find function. And what it does is return the lowest index in the string where a substring is found within our word. So for example, if we want to find the first occurrence where it's located in Mississippi, the word I, or the sequence of letters IS, we know it's located at the first location. Now, of course, you may say, well, wait a minute, I is at the second location. One thing we haven't talked about yet is Python starts counting at 0. So M is at the 0 location, I is at the first location, S is at the second location. So we start counting at 0, not at 1. It's something called zero-based indexing. That may not make a lot of sense to you right now whenever we talk about arrays toward the end of the class. It may make a little bit more sense, but just keep in mind that whenever we're dealing with strings like this, whenever we got 1, it is actually referring to the second letter, not the first letter. Actually, the first letter M is at the 0th location. So if you tried this, typed out Mississippi.find and then put M in here instead of IS, it'll output the value of 0. So I'll leave that as an exercise for you to look at. Another function that we'll be looking at is the format function. And format returns a string that replaces space holders in the string with values in the argument list. So for example, you can have a string, and what it does is it looks for this occurrence of the swiggly bars. I don't know, swiggly bars. I don't know if that's really the proper name for them, but it looks for that, and it knows that whatever the value is here to substitute that in here. So for example, it would say, I love CIS202. So it takes the 202, puts it in where this is here, and outputs this. Now we can use, instead of hard coding a value like 202, we could create a variable called instructor or any variable that you want. We can put my name in it, and we can have string.format instructor, and it knows to look for this and then replace wherever this is in the string with the value of instructor. Now both of these are close to the end of the string. Notice that this has the exclamation point there, which goes there. So technically the 202 isn't at the end, but somebody glancing at this may think, oh, it just puts that at the end, whatever the value is here. That isn't what it does. It looks in the string for where this is located, where this placeholder is, and then puts this value in that location. On the other hand, moving on, we can have more than one value here in our format. So for example, here's a string to where we have more than one. We have one placeholder here and then another placeholder here. And so we have two variables here. In this example, I'm hard coding the values, but you could use variables here instead of these hard coded values. But I have CIS202 that'll be placed here in the first placeholder, and then my last name Ernie is put here in this location. So the output, and this should be a string, there should be a tick mark in the front here, a tick mark at the end. I'll try to make this correction in the notes before you download the notes, but it should say I am enrolled in CIS202 and my instructor is Mr. Ernie. So you can copy and paste this into Thony or some other Python compiler or shell and see if it outputs this value, which it should. Length of a string, quite often we want to know what the length of a string is. And this syntax is slightly different than some of the others that we've seen. And later on, I'll explain why it's this way. But instead of having the string and then dot length, it's just len open parenthesis, the string, and then close parenthesis. So here, if we have a string that says, this is my text, you can say length of A, and it will return 15, which is the number of characters in that string. There's another function called lower, which what it does, it takes a string and it will put the every character in lowercase. So if you have a string ABC all uppercase, it'll look at each character and will convert it to its lowercase equivalent, ABC. If you have something like this to where only some of the letters are uppercase, it will the lowercase letters, it doesn't do anything to it, just converts the uppercase B, and so we would get the same value that we see here. Sometimes we have a string and we want to actually strip characters from the beginning of the string. Quite often we want to do this whenever we have a bunch of blanks and stuff at the beginning of a string. Let's say, for example, that we have some kind of a string like this with a bunch of spaces at the beginning. If we don't specify characters up here, which this open bracket, close bracket means that this is optional. So whatever's in here is optional. And if we leave that out, it defaults to like a space. And so it knows to look at everything at the beginning here. And L represents left. So it's left strip. It's going to strip everything out that's at the beginning, or the left of the string, or the left part of the string. And so since this has open and close parenthesis, it means that it's going to look at spaces. And so it removes all the spaces at the beginning, as we can see here. If we have a variable string called civic, we want to strip the stuff at the beginning that is a C or an I, and it doesn't necessarily have to be in that order. It's just either of those characters. It'll remove the two characters at the beginning that are a C or an I. But once it hits a character that is not in this list here, this string, it knows to quit. So it returns VIC. Radar, if we want to strip out A and R, it'll strip out the first R and A, and once it hits D, it just leaves everything else alone. So here's another example. This is a string. We want to left strip TH, so it starts at the beginning of the string and it removes T and the H. Once it hits the I, which is not in this string here, it knows to quit, and so this will return is a string, removing all the T and H's that are at the beginning of the string. So look at these examples, maybe put them in Thony, maybe try a few other examples, see what works, see what doesn't work. If you're still having some issues with the lstrip, maybe go to Google and type in Python space lstrip. There's tons of examples. If what I'm explaining here doesn't seem to make sense, one of those Google searches should produce something that makes sense to you. And of course, worst case scenario, you can always email me or send me a Blackboard message, and I can try to get that resolved for you. I can try to give you a few more examples. If I need to, I can go in here and make some modifications to my notes to make it a little clearer for future classes. Another function is the replace function. And what it does is it will replace part of a string. So for example, this is the syntax for it. We have a string and then the word replace. We have the old text and then some new text. And then count here says the number of replacements we want to do. And if we don't put anything there, notice this, we have the optional. That's what the left bracket and right bracket represents in almost every programming language. If you see this with syntax, it almost always means that this is optional. So that's why I put this here, is because once you learn this syntax, you learn the way this looks, you'll be able to look at other programming languages and be able to quickly find out what this stuff means. So let's look at a few examples. Let's say we have the string hello world. And what we want to do is every place where we have the value of world or the text world, we want to replace that with Billy. So instead of having hello world, we can replace that with hello Billy. Here's a string that says this is another test. And what we want to do is in every location where we have, or in the first location, I'm sorry, not every location, since we do not have a count here, it only replaces the first occurrence. Notice what it says up here. So I misspoke. It only replaces the first occurrence. Now, if we want more than one occurrence, we put a comma and then the number of occurrences we want here. If we want all occurrences, there may be a way to do that. I think there's a function that's called replace all, where you could put a comma and then some really large number here like 99 or something like that, and it would replace all occurrences. But the proper way to do this is, I believe there's a replace all function, and if that's the case, you'd want to use the replace all instead of the replace if you wanted to replace all occurrences. But quite often that's not the case. We only want to replace a single occurrence or a certain number of occurrences, or up to a certain number of occurrences. So getting back to this example, this is another test. We want to replace another with the, and so this would return this is the test. Now, remember earlier we had L strip. Here we have R strip, which means to return a copy of the string where the ending characters, the stuff on the right, is removed from the string. So looking at the same examples that we did before, but replacing R strip or L strip with R strip, this will, since we don't put any characters in here, it knows to use the definition of R strip is to if this is empty in here, if there's no arguments, to use the white space or a space as the character we want to remove. And so what happens here is all these characters here at the end, it starts at the end and works from the last location in the text moving toward the front, and all of these empty spaces here are removed, as we can see here. In this next example, we want to do the exact same thing, starting at the end and removing all occurrences of I and C. And so we move until we find an occurrence that's not an I or C, and so it starts at B, so we get CIB. And with radar, it removes the last A and R. Once it hits a D, it stops, and so this returns rad. Now, there's also a function called strip that will return, that will look at the beginning and the end, and will remove those. And so in this example, where we have A, B, C, and strip, this is the same thing as doing an L strip and an R strip at the same time. And so what it will do is it will start at the beginning, remove all of the, since this is an empty argument list here, it knows to use the space. And so it knows to go through here and remove all of the spaces at the beginning, and then it starts at the end and removes all of the spaces at the end. So we end up with ABC. With Civic, we want to strip all of the leading and ending occurrences of I and C, and so we end up with V, as we see here. And Radar, to make this a little bit different, I just wanted to put an R there, even though in the other examples, like up here, I have AR. It will remove the R at the beginning and the end, and it just ends with ADA. If we have this text, this is a string, and we want to remove TH. Because there's no TH at the end, it only removes the 2 at the beginning. We have this, is a string. And our last function that we're going to look at, and of course there's many other string functions, but we're only talking about the really popular ones that you will use quite a bit in a lot of programs. There's a lot of other string functions that you can use, and so You can go to Python, you can go to Google and type in Python string functions, and you'll get a ton of lists of other functions that you can use in a string to do lots of neat things. The last function we're going to talk about is upper, which what it does is it takes a string and converts all of the characters to uppercase. So if we have XYZ, lowercase XYZ, it'll convert all of those to uppercase. Hello converts that all to uppercase letters. Now, since we've talked about all of these functions, there's another very important topic for us to talk about is how to format output, and this deals mostly with numbers. There's times that we want to customize how output is displayed. For example, let's say we have a variable called pi, but we're only interested in displaying it to so many decimal places. Like the first 6 or 7 decimal places of pi is 3.1415926. But to make things a little easier, maybe we only want to display it to 3 decimal places. And so we can write something like this, where we have the percent. Remember before we had the %s, which means output this as a string. Here we're saying take this value and output it as a number, a floating point number, where there's 4 numbers total, and 3 of the numbers are after the decimal point. So what it will do is take this value here, and then it will try to convert this so that there's 4 numbers total, 1, 2, 3, 4, and 3 are on the right side of the decimal place. And so it'll take these 3 values, and what it will do is to get it to represent the value as close as possible is it will round. It'll look at the next value, which in this case is a 5, and know to convert this 1 to 2. So this is the value that's outputted. We can also use the format function that we've already talked about with the string. We can write it like this, and it will produce the same result. So you can use either of these. This is equivalent to this. The reason why I show you both of these is because some older Python code writes it this way. Newer Python code quite often will write it this way. And so if you're looking at Python code, you need to be able to understand both formats and be able to know how it's working. What I suggest that people do is if they're already looking at some code, and if it already uses one syntax, like this syntax, continue using this syntax, unless you're wanting to go through that whole file and convert it. But if you see that all the code is this way, stick with this. There's no need to go in and write some of the code like this where you're moving back and forth. Try to stay consistent. Now you may say, okay, well, here's an F here. What other values can we use? Here's some other values that we can use in a string like this to specify how to format our numbers. We can put a B, a value of B, to say I want the binary representation of this number. A C can represent a single character. D is the decimal integer value, which is the default that we normally see. E, or uppercase E, is the exponent. F, which is in the example that we've seen here, will do the floating point value. A G, or an uppercase G, depending on the number, will do the floating point or the exponential, depending on the value of the number. O is for the octal integer, which is the base 8. X, or uppercase X, will do the hexadecimal, which is the 16-bit value of the number. And the percent, which is the percent format. You can put a percent, and it will output the percentage format for that value. So let's look at a few examples. So we can have a string here that tells us how to format our number. And this just says use the integer D for decimal. You can just think of it as an integer representation of 42. That is just 42. Or we could write it in the newer format uh, using the format function like this and same output. Here we can write the floating point representation of 2.78. And what it does is it actually appends a few zeros onto the end of that, or you could write it using the format function and we get the same value. If you want to find the hexadecimal value of a number, let's say 30, for example, you would use an X, and 1E is the hexadecimal representation of 30. If you don't understand that, go to Google and type in hexadecimal and you'll learn everything you want to learn about hexadecimal. I would suggest to go ahead and learn what hexadecimal is because it's used quite a bit in computer science. You will see it used quite a bit, and so you need to get comfortable with it. You might as well learn what it means now, because in future classes, you'll see it, you'll need to understand it. So definitely spend some time learning what that is. In most cases, we're going to use just base 10 because that's what we're used to, but know that this is available just in case if you need it. Now, one other topic dealing with strings that I want to talk about is something called F strings. F strings is new in Python 3.6. F strings allow for an easier way to provide string formatting. So for example, notice that up above here, we had to have a bunch of, like a format statement, or we had to have this percent and then number, several numbers or variables or whatever. With an F string, we can just put the variables inside our original string, and within the squiggly brackets, put the name of the variable, and Python knows to make that substitution automatically. So this is actually a little bit easier to read. It says, hello, my name is name, which replaced the value that's in name up here, which is Billy, and I teach course, whatever values in course, which is CIS202. So this is a little bit easier to read than if you had like a %s here, and I teach %s, and then you'd have a percent name, comma, course. And let me actually show that since I don't have it in the examples. Is that what it says? I teach. And I teach. And what I will do is just hard code the values here instead of creating variables. Oops, what did I do wrong? What did I do wrong? Okay, I think I know what I did. Yeah. You see what I had to do here to get that to work right? I had to write it like that. Now, isn't that a little bit harder to read than what this is? I think it is. Older Python code will look more like this, and newer Python code will look a little bit like this. And a lot of your older Python programmers that's been doing it more than about 4 or 5 years are in the habit of writing it like this, which I am. And so quite often you'll see me write code like this, but I am trying to slowly convert over to stuff like this because it's easier to read. Also with F strings, you can do something like this to where you can do arithmetic within the F string and it will do the arithmetic for you. You can also, whenever we get into functions, for example, which is something we'll talk about in a few chapters, in a few weeks, you can actually refer to functions within these and it will execute the code for you. Now, here are some exercises that you can go through if you'd like to see that you've got a better understanding of strings and how they work. Here's also a link to string documentation on the python.org, the official Python website. Feel free to go read that, get a good idea of a lot of other string methods and how they work. Strings are used a lot, and so you need to get used to how they work. So please spend some time doing that. The last topic I want to talk about today, and I know this is a long lecture, is basic input output. Basic input means getting input from the user. Output means displaying something to the screen. How we display data to the screen is by using a print statement. So the basic print syntax is like this: print args. You may think, okay, what does that mean? The easiest way to describe that is like this, where we do a print statement and then whatever our variables are that we want to print, which in this case is some text, and it outputs hello world. I'm thinking there's supposed to be ticks around this. Let's see if that's supposed to be the case. Let's see if I made a mistake. Nope. And with the print statement, it just outputs it like this without any tick marks. That's one reason why I think I've had a little bit of problems with some of the examples that I've had where I've left out tick marks is whenever you use a print statement, it doesn't display the tick marks. Whenever you just output the results in a shell, it does have the tick marks. So it's a little bit confusing, but that's the way probably to remember is with print statement, it just prints it out without the tick marks. So you could also remember, instead of just using the double tick marks, you use single tick marks and print it out like this. You can print out an integer value or you can print out a bunch of values. So instead of just doing hello world, you can output several values. So you can have a string and then numbers. As you can see, all these are integers and then a number, and it prints out all what those are. You could also have floats or whatever you want in there. They all don't have to be the same type. And what the print statement does is it'll take whatever these values are, it'll find the string representation of that, normally by using that str function, and will output the results. Also, you can print out a variable like this, where you have a equals 1 or any value that you want, output variable a, it knows to print it out. Like in what I just showed here, you can say print your age is blah, and it will output your age is, in this case, 25. I'll leave that up to you as an exercise, see what the output is. This also will print out the same thing to where we use the percent age, because what it does is it will, remember what this did before. Your age is percent %s. What it does is it takes the value that's in age, puts it here, and returns a string. So since the value of 25 is in age, and say your age is 25, then it prints out that whole string. Also right here, it'll do the same thing with an F string, and I think I've left off the F there. Let's just see if this works. Say print your age. Oops, let me set age equal, and instead let me say 21. Let me use a different value. I'll say print your age is age, and this will probably produce an error. Yeah, no, it doesn't. It'll just print out what this is here, the string. It does not do any processing of that. If we want to process that where it's an F string, we have to put an F in front of this, and then it knows to do that change. So know these differences. Know when it's going to do one versus the other, and I will go in and make the changes to these lecture notes so that this is correct. Excuse me. So that is output in a nutshell. It can get more complicated than that, but that's the basics of it. We'll look at more of those throughout the semester. Input is pretty simple. We use the input function and then some string here. If you don't put a string there, it asks for input without prompting you. And usually what you want to do is you will want to put something there because you don't want it just to sit there and the user not know that it's prompting. So you'll put text there like this, type in a greeting message, hello, and then whatever the user inputs, whatever string they enter, they type in and then press the enter key. Whatever that is put in this variable called greeting. So the greeting variable will contain whatever typed on the keyboard. Input stops accepting keywords when the user presses the enter key. A string is returned. Input will always return a string. So if I typed in hello, like what we see here, HELLO, with the exclamation point, and then I print out greetings, it'll output hello. Here's another example. We could ask the user to enter a number and we will find a square. So we could say input and we type this in and let's say the person typed in 5. The value of 5 is put into number. And remember what I said a minute ago. The input always returns a string. Like what it says right here. The value returned from the input function is always a string. So number is equal to the string 5 or to the text 5. So whenever we print number times number, we get an error. And why is that? Because to do the arithmetic, Python doesn't know how to multiply a string by a string. It does know how to multiply a string by a number, but it does not know how to multiply a string by a string. And if you don't believe me, try it. Let's see. Let's try 3 as a string times 3 as a string. We get an error. It says cannot multiply sequence by non-integer of type string. So what do we have to do? Whenever we get input from the user and it's like a number, we need to convert that to a number type. It needs to be a float or an integer. Now, how do we do that? Remember a few minutes ago, maybe about 30 minutes ago, we talked about 2 functions, one called int, int, and the other one called float. And so what we can do is we can take the float of the number. This will actually store the number representation of that value. And then whenever we multiply to find the square, it'll output the right value. If we know that the number is going to be a whole number like an integer, you could use a float. If you're not sure, you could use a float value. And the last thing I want to talk about is comments. Whenever you write code, you want to write comments to explain what you're doing. And the way to do that is we start a comment by using the pound symbol. And we can do that anywhere in our code. For example, it could be the first character of a line like this, where it says this is a comment, or it could be after we write some code like the print hello world. Out here to the side of it, we could write a comment. And so what I would do, like up here, maybe it's time to output to display our output. So instead of writing this as a comment where it says this is a comment, maybe I put here, now is time to output our results, or now is the time to greet our user, or something like that. And then you could write that. And so what comments allows us to be able to do is it helps future programmers or yourself, if you're reading this so many months in the future, to understand what's going on and the reasoning behind your programming. And it just helps to explain what's going on in your program. Now, you don't have to go overboard and write tons of comments, but it's good to write some comments here or there to explain what's going on, especially in pieces of code where something is complicated or it's a little bit hard to understand. So here are some in-class programming exercises. Feel free to go through these, try to get an understanding of what's going on. Here's an in-class programming assignment. I'm not going to cover this. This lecture has been extremely long, but feel free to go through this and see if you understand what's going on. And then there's also some additional exercises here if you would like to go through those. So that's about it. Thank you for watching this video, and I will see you next time.